now. So we are at 5, 4, 3, 2.
Welcome to Janet's Planet, where we're traveling at the speed of thought. Welcome to the Janet's Planet Online Astronaut Academy. I am delighted to bring you experts from around the world in the space industry right into your home with your children. And today is very special. With a command performance, we have my good friend, Kevin J. DeBruin. He is a rocket scientist. He's an American Ninja Warrior, and he just applied to be an astronaut. And I'm just going to go on the record and say, NASA, this guy is an awesome astronaut. He's an astronaut. Take him. He's going to be great. So without further ado, everybody give a good virtual welcome to Kevin J. DeBruin. Thanks so much for being here.
Well, good morning, Janet. Thank you. Good morning, everybody. I appreciate you inviting me on and putting up this Janet's Planet every single day, being consistent with it. I see some of our old space cadets in there, our campers. Seeing Lucas, how you doing? So I'm excited to tell everybody all about my journey to getting into NASA and then some of the missions I worked on there. We're going to learn where the best place is to find aliens in our solar system.
Woo! I love it.
All right. So can I share the screen? Am I good to go?
You are good to go. Now, we have found that sometimes if I get, you guys know that if you've got some questions, and hey, Victoria, good morning. Glad you could join us. So text me if he gets to a slide and you've got some really good questions, text them to me or put them in chat. And then what I will do is I might say, hey, Kevin, we got a great question out here, but otherwise we'll let you kind of proceed. Yeah. And you're always willing to go, willing and able to say, wait just a minute, let me catch up with that thought. But I don't want to lose any great questions we might have from either online or here in the chat room.
Okay, there we go. Got to make them viewable. Okay, can you see this? You see this nice,
cute,
beautiful landscape we have here?
Gorgeous.
All right. So this is NASA. This is NASA's Jet Propulsion Laboratory in Pasadena, California, or Los Angeles. And right here, these are all the buildings where we design the Mars rovers, the robots that NASA sends out beyond the moon. So to Mars, the asteroid belt, to Jupiter, to Saturn, all the way out to beyond like the orbit of Pluto at the edges of our solar system. All of those spacecrafts were designed in these buildings here. Now, can you see my cursor? You see this arrow moving around?
We can.
You can? Cool. So you see this building here that's kind of like blue. It's got some nice windows. So that's where I used to work. That is where I put all of my knowledge, know-how into the computers, working with friends, colleagues to help design these spacecrafts. So a little bit more about me. So I'm literally a rocket scientist, and that is my favorite thing that I get to say because I wanted to be one for so long and I finally made it happen. My official job title at NASA was a systems engineer. So my job as a systems engineer is, think of a spacecraft as a complex puzzle, and you have to put this puzzle together the right way. So my job is to make sure that all the pieces line up, all the right information goes back and forth. We've got enough power from our solar panels or like our nuclear reactor or our batteries to make sure everything is turned on, operating, and good to go. So I needed to put the whole thing together to make sure everything was going to work. We were going to be low enough in our mass, so not way too much so we can get off the surface of Earth a whole lot easier, or land on another planet or a moon easier, because the more you weigh, the harder it is to land somewhere else. And then as Janet said before, I am an American Ninja Warrior. That is something I also like to do. It's playing on an adult jungle gym. And I'm going to show you in just a second, actually a video of me doing that. And then lastly, I'm an Eagle Scout. So Eagle Scout is the highest rank you can achieve in the Boy Scouts of America, which is now called Scouting of America, which allows girls to go in as well. So if you're looking for a good place to find community, get some leadership skills, you like to go maybe camping, learn some outdoors, some orienteering, pioneering activities, become part of scouting and go all the way to Eagle Scout. So that has helped me get college scholarships, helped me get my job at NASA. They looked at my resume, which is the piece of paper that says all the things that you've done in like school and work. And they're like, oh, wow, he's an Eagle Scout. We're going to put him in a special pile, and we're going to take a second look at him after we get through all of these other ones. So that's a good thing. Now I'm going to show you me competing on America Ninja Warrior. All right, let's share this one. See this big screen here?
Mm-hmm.
See me ninja? All right. So here it is. You can see the big logo, so it's real. So this was me competing on American Ninja Warrior here in Los Angeles a few years ago. This is the best video I got. It was me and my rocket logo on the back. So I was super nervous. This is like at midnight. They make us run the course during the night, which is why it's always dark. There's a bunch of other rocket scientists from NASA. They came to support me on. They were cheering Rocket Man the whole time while I was running. This one is called the floating steps. So they each go up, and they're further apart. As you go to the top, you got to jump on a rope and get to the end. So I went through that one, felt a little wonky as I was going. You can see I got the American Ninja Warrior jacket on right now to represent. So now we go up to the second obstacle here. So this one, it feels like a basketball. You got to hold on to the basketball, and then it drops and it drops, trying to throw you off. But then I was able to make it to the final platform, and I'm super excited because I'm like, whoa, this is awesome. It's like I'm going to space, but not really. It's just, I feel like I'm flying at this point. I jump on the trampoline, so you can see these wheels spin. So I got to generate some momentum, move my body to throw myself to that next wheel and jump. Okay, so I made it. Cool. Now I'm getting tired. This is some tough stuff. Like,
I don't know.
tax
I
my
don't have
brain.
that kind of like upper body strength. This one always amazes me.
So you see this wheel spinning, you jump to the last one. So it doesn't spin, but it's like a swing. It's a pendulum that goes back and forth. So to make it move is a little bit harder. So I'm like, oh, I can step on the platform, and no! Oh, so I fall back into the water. I didn't complete the course. I tried. It's gonna give us an instant replay in a second. So you see, I made the jump, I was good. And then I thought I could just step onto the platform and walk off, but I didn't have enough momentum going forward, and it brought me back into the water. Oh,
Which is a great example of Newton's law, right? For every action, there is an equal or opposing reaction. Did you go over in your mind 1,000 times of how you might have tried that move? Or is it kind of like, you know what, I did my best and this is the result?
I have gone over it so many times. So let me show it again. I'm going to show you a part right towards the end. So you can see I changed what I was going to do right at the end. I'm going to zoom it in. So, okay, right when I click play, you're going to see my face kind of smile and my head go up a little bit. All right, did you see that? So that's because on my first swing forward, I was actually able to do this same thing and touch my foot. And I was like, oh, and I heard the audience also go, oh, because they're like, oh my gosh, he's like so tall, so long that he can just step off. So at that moment, I changed what I was going to do in my head from throwing myself off of it to land safely to I'm going to make this look cool, and I'm just going to walk off. Always take the safe route. Be better safe than sorry. Don't try and make it look cool when you're competing in American Ninja Warrior. At least for me, that was where I went wrong. So it's nice that I have the footage to look back and to show people, here's where I went wrong, but it also hasn't stopped me from wanting to do it again. So I failed and it was awful, but I see where I can get better. And with school and with being a NASA rocket scientist, like I'm always challenging the brain. This is a physical challenge, but it also challenges the brain because you're failing, you're falling in the water, you're getting wet, you need to get back up and try it again. So I competed the next year, and then I've taken the last year off to test the obstacles. So what that means is all throughout the year, they come up with new obstacles and they call me over. They're like, hey, Kevin, we've got some new stuff. We want you to come play on our jungle gym and let us know if it's too easy and it's too hard as they're building up and getting ready for next season's competition.
Very, very cool. Guys, really hear that in the message. It's like, you know what? If you're trying something, there's a very good chance that you will find some failure. Then you're going to figure out a better way to do it next time. It's a brilliant application for science.
Okay, there we go. All right. Are we back to seeing the pictures of me with NASA?
Uh-huh.
All right. So in the bottom left-hand corner, you can see there, that's me in front of a rover. Does anyone know that rover? That is Mars Curiosity. That is a life-size model. So that's how big it actually is on Mars, roving around. And then in the middle, that's me with an astronaut glove, as I'm getting prepared to be a real astronaut maybe one day, with the moon Europa behind me, which I'm going to tell you all about. And then lastly, that is my car in front of the NASA JPL sign, because I just thought it was really cool and I wanted to take a picture. Let's see. There we go. So my motivation. So this is why I am a NASA rocket scientist. So this is the movie October Sky. And I saw this when I was about 10 years old. So the age of some of you out there. And at that point, I saw what the movie is a boy who designs rockets with his friends, launches them, wins a science fair, and eventually becomes a NASA engineer training astronauts. And I thought that was really cool. And at that point, I knew that I wanted to design spaceships for NASA. And it's based on this book, Rocket Boys. It's a true story about Homer Hickam Jr. going through this process of falling in love with rockets, building them, and becoming a NASA engineer. And the reason I share this is because sometimes life is tough, right? School gets hard. Sometimes you don't do good on homework or you're not really understanding something. And I had that happen to me a lot as I was trying to become a NASA rocket scientist. So whenever it got tough, it got hard, I wanted to give up and I wanted to quit, I would go back and watch this movie because it was the why, the reason I'm doing everything. Because I could get so in my head, or I lose focus of what is the end thing? Like, why am I doing all of these math problems, all of this homework? Like, it doesn't feel real to me. So I'd watch this movie like, oh yeah, that's right. I'm doing this because I want to design spaceships for NASA. So I hope that whatever you decide that you want to do for your career in life, when you grow up, what you want to be, you've got a reason of why, because it's going to get tough and you need something to try and help you through. So one of the biggest things that helped me through was to rewatch this movie or reread this book to get that inspiration and motivation, the reminder of why I'm going forward to do exactly what I'm doing. Now, it wasn't too long ago, like I said, 10 years old, when I was sitting in your seats. So I'd like to show you this to take a look at where I was when I was sitting right where you were in either first, second, third, fourth, fifth grade, sixth, seventh, eighth grade, that it wasn't that long ago. So I'm not super old, right? I feel old sometimes, but I haven't changed too much, have I? But I did grow up. So I went into high school. Then when I went to high school, I have college and then grad school. What does this mean? Well, we saw first through eighth grade on the last slide, right? So freshman, sophomore, junior, senior's 12th grade. And then for college, I went all the way to 19th grade. So I have a master's degree in aerospace engineering that required 19th grade of graduation. I went all the way through that. So if you're in, ninth grade right now, or if you're in eighth grade, heck, if you're in fourth grade, if you want to do the same amount of schooling I did, that's 15 more years of school. Okay, so that seems crazy. It seems like a lot, but that is what is required, that amount of schooling to build spaceships, right? To design spaceships for NASA. If you want to be a scientist specifically in like chemistry or biology, you need even more school than that. You have to go on and get your PhD or your doctorate. I don't have that. You can't call me Dr. Kevin. Some people try and I'm like, nope, I don't have that, just a master's degree. But if you want to do the science portion of it, then you need to go on and even do more school. So just lay in the path ahead that it's a lot of school because we're doing things that have never been done before. We are going to places that sometimes have never been explored before. We're trying to do new things. It's not like, in school where you fill out your homework and the teacher's got an answer for you. We need to find the answers ourselves. So it requires a lot of time and dedication to build these rockets, to build the spaceships, to understand the science. to know what to look for and how to answer these questions. So questions, this is the fun stuff, right? So American Ninja Warrior is pretty fun, but now we need to get into the space side of things. So here's our solar system. So we've got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We got our 8 planets. Now I'm going to tell you about Europa. Have you ever heard of Europa before? Hopefully, not all of us have, but it's around Jupiter. So we've got many moons in our solar system. Earth has 1, Mars has 2. Jupiter right now has 79 that we have found. Saturn has even more at 82 right now. So there's more moons out there. These are just the ones we have found so far. So if we're at Jupiter, so let's bring it up. These are the 4 biggest moons of Jupiter. We've got Io, Europa, Ganymede, and Callisto. Now, they're not this close. They're a lot further apart. But Io is the most volcanically active body in our solar system. What does that mean? Well, that means there's volcanoes. There is more volcanoes erupting on Io than anywhere else, including Earth. So it's just spewing stuff out into space, just volcanoes launching. Europa, the best place to find aliens. I'm going to tell you all about that in the next couple minutes. Ganymede is the largest moon in our solar system. It is bigger than the planet Mercury. And then Callisto is what we believe to be one of the oldest bodies in the solar system. You see how there's a lot of white spots on it? So those are like dents. Like on the moon, we see things like this. We got craters. So something from space, like a rock or ice or piece of metal, will come in and hit the surface of a moon or of Earth, and it leaves a dent. So Callisto has the most dents of anything that we've seen in our solar system. So we believe it to be one of the oldest things here. But Europa, that's the important one for me. So Europa is the best place to find aliens in our solar system. What? Why? I'm gonna tell you. So look at it. It's beautiful, right? It's blue. It almost looks like a marble. If you've ever played marbles, it's blue. It's got some red stuff on it. It's about the size of our moon, but we believe it has about 2, maybe 3 times as much water as all of Earth. Okay, why? Because Earth is like 70% covered in water, right? Well, the Earth's oceans aren't that deep. And when I say aren't that deep, it means on average, and we're going to the metric system here, like Janet talked about, they're on average about 4 kilometers deep, with the deepest point being in the Marianas Trench, around 11 kilometers. Now on Europa, we believe the ocean is all the way around, and it's about 100 kilometers deep on average. So really, it's just a ball of water that's frozen on the outside. So the surface here, what we're seeing is blue, is an icy crust that's maybe 15 to 30 kilometers thick. And underneath that is a vast saltwater ocean. And in that ocean and on the sea floor is where we think is the best place to find life. That's awesome. So why? Why is it the best place to find life? It's water. It's way out far in our solar system. It's out past Jupiter. It's no sun can get there. That's like super strong. So what's going on? Well, for life as we know it, these are the ingredients. So we are carbon-based life forms, right? We only know life as we know it. So there could be other types of life that isn't like us, but that's going to be harder for us to find. So first, we're going to look for things like us. The first thing we need is water. Where we find water on Earth, we find life. If you take a spoon, you go to the ocean, just get a spoonful of ocean water, there are millions of little organisms inside that just one spoonful of ocean water. So Europa is a big ball of water. It's frozen on the outside. We can check that box. Now, chemistry. We need the building blocks of life, the things we find in rocks. So we're looking specifically for carbon. We're carbon-based life forms. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. So those are some big words. You may have not heard of them, but CHNOPS is the abbreviation for all those words, and that's how I remember them. Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And I say schnapps. If you put all those letters together, that's kind of how you can say the word. So
say that again. I'm going to put that in the chat. Spell that. Is it an acronym kind of thing? So spell it again. Mhm.
N-O-P-S.
Schnapps.
Carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur.
Awesome.
Some people say knops, but I don't think that's that fun. I like schnapps because then I can say to the adults, you know, we need schnapps to create life, and that's an adult joke. So we need the
Awesome.
water, we need the chemistry, and then energy. So we need a way to power life. So here on Earth, what's this thing that's like really bright outside, you know, that helps our plants grow? The sun. So the sunlight, plants use it in a process called
Hey,
photosynthesis.
Kevin, before
Yeah.
you go, I think this is such a great question because this does go to why Europa has life. The question is
go.
this is from Jennifer Wagaman, why is Jupiter a gassy planet, but not its moons?
Why is Jupiter a gassy planet, but not its moons? Are you still able to see my slides, by the way?
Uh-huh.
Okay, cool. Because I've got questions coming in here in the chat. I just was able to see if I could see them.
Yeah, it's
So
like
why is Jupiter a gassy planet?
Mhm.
So from my understanding, that at the early formation of our solar system, so things are flying around and gathering in, that the rocky planets formed closer to the sun and our gaseous planets formed further away from the sun. And the reason that the moons are rocks is because so Jupiter is so massive that it's got a bunch of gravity. So gravity is what, if you drop something, it drops, it falls down. And that as things are flying throughout the solar system, so there's things that come from the outside, there's things moving all over when it was first forming, is the gravity of Jupiter pulls it in. So the gravity of Jupiter pulls in these rocks and turns them into moons. So originally they weren't all around Jupiter. There were pieces scattered all throughout the solar system. And then over time, Jupiter's big massive gravity has pulled them in together. So then lastly, so the energy. So we just talked about the gravity and the moons. So the energy, the way that powers life out at Europa. We saw those 4 big moons from before, Io, Europa, Ganymede, and Callisto. So they push and pull on each other. So I got this little ball here. So think of this as Europa. Europa gets squished and then stretched, squished and stretched. So it's getting bigger and smaller because it's getting pushed and pulled on by all those moons. Now put your hands together and start rubbing them. What do you feel? It gets warm because there's friction. So when it's moving, like Europa's moving, creates friction, it creates warmth. And what that can lead to is you see that image on the bottom right, those are like underwater volcanoes. So they're things like hydrothermal vents, we call them chimneys or black smokers. So this is actually a picture from our ocean floor. And this releases salts and minerals and heat into that ocean. And that's what allows life to live. And they use chemosynthesis. So chemo meaning chemical, synthesis for energy. So chemical synthesis instead of photosynthesis. And we find things like hairy snails and fish and other forms of life down, way, way down deep where the sunlight can't reach on our ocean floor. So we think that same process is going on out at Europa. And also this right here. So plumes. Europa has plumes. So we saw those cracks, right? All these lines. Well, we believe that the lines are breaking open and that some of the ocean is shooting out into space. So we use the Hubble Space Telescope to get these observations. You can see these little blips that show us, hey, there's water coming out of Europa, and it could potentially look like this. So if there's water on Europa coming out, we might be able to like sample that ocean without actually going into the ocean. Because it's going to be really tough for us to like get through that ice shell, get down into the ocean. Well, what if that ocean came to us? And that's what it's doing here by plumes. So plumes are like, if you've ever seen someone knock over a fire hydrant with a car, which is not a good thing, but then the water shoots up, it's kind of like what's going on out at Europa. And it's not the only place we find this in our solar system. There's another moon, a couple other moons that do this as well. So if we can use a spacecraft to maybe fly through some of the the water and grab that, then we can look in that water and see if we're finding the aliens. So maybe some aliens got shot out in outer space too. So Europa Clipper, this is one of the spacecrafts I worked on when I was at school and then while I was working at NASA as well. So it's a spacecraft that we're going to launch in 2023. So this is just an artist drawing of what it's going to look like. We've got solar panels here. Oh, I want to go back. Solar panels, which are those big wings on the side, and that's how we get the power for our spacecraft. That big circle on the top middle, that's our antenna. So that's how we call home. We're like, yo, Earth, we found this really cool stuff. Or what else do you want us to do? Where do you want us to look? And then you see all these other things that are sticking out and pointing out on the spacecraft. And those are different science instruments.
How long does it take transmission to go from Earth to Europa?
So it travels at the speed of light, which is 300,000 kilometers per second, or for all of you non-metric people, 186,000 miles per second. And so Jupiter and Earth are both moving around the sun, right? So sometimes they're closer, sometimes they're further apart. So it takes somewhere between like 30 to 60 minutes to communicate with Europa, or with Europa Clipper when it's out there. So we can pick up the phone and we say, hey, Europa Clipper, make a left. And you got to wait 30 to 60 minutes before it hears it and goes, oh, okay, I'll make that left. And then if it makes too big of a left, then we got to wait another 60 minutes for that to say, come all the way back to Earth. So it takes a really long time for us to steer our spacecrafts when they're out at Europa. Like at Mars, it can be anywhere from like 3 to 10 minutes. You know, that's not too bad. But out at Europa, it's so much further away out at Jupiter that can take up to an hour. So think about that. Think if you were driving with your parents or your guardians in your car, and they were asking you which way to go, and you had to tell them to turn left an hour before they had to turn left. It's going to be pretty tough, huh? So that's one of the challenges we have with space exploration, is being able to plan so far in advance. So speaking of turning left and planning in advance, when we launch Europa Clipper, this is what it's going to look like once it gets to Jupiter. So you see these lines. So this is the spacecraft's path as it's flying over the course of about 2.5 years. It's going to take 2.5 years to make all of these loops, about 45 loops around Jupiter, and then fly by Europa. So what we see on this right hand here, we'll play this again so we can see them. I'm trying. There we go. So on the left-hand side, we see the path of the spacecraft, and on the right-hand side, all those little lines are where it's flying by Europa. So we're orbiting Jupiter, which is here in the middle, and then Europa is this blue orbit here, if you can see it. And we're doing that because Jupiter is so massive, it's got so much gravity, it pulls in a lot of electrons and protons out in space, which create a huge radiation environment. So you could think of Jupiter, like the close part to Jupiter, as a really massive microwave. And what do we not put in the microwave? We do not put metal, we do not put electronics, because it's bad. So we don't want to be close to Jupiter, close to Europa that long, because our spacecraft gets all charged up. So we take a small amount of time, about 10 hours, to get really close to Jupiter and Europa to collect our science. And then we do these long looping orbits. You can see we go really far away and then come back in to save our spacecraft. Because otherwise we get all charged up and it would fry our electronics. They won't work anymore. So each time that we go through one of those, what we call a flyby, as we're going close to Europa, it looks like this. So we started about 66,000 kilometers out. And as we come in, these different colored bars are different science instruments turning on. So this blue and pink is a camera taking pictures forward and backwards to give us high resolution images of the surface. Because we really want to know what it looks like. And then we have things like a ice penetrating radar. So it's a radar that goes through the ice to let us know how thick it is. Because we think we know how thick it is. We think we know how deep the ocean is, but we need this spacecraft to confirm our hypothesis or tell us new information. We also have a thermal imager, which tells us, you know, the different heat signatures. Is it hot? Is it cold? We have a topographical imager, so we can see are there mountains, are there valleys, but it's not mountains and valleys, so it's just ice. So is the ice broken? How deep is the ice? Is it Is it level? Is it smooth? Or is it all rocky and chaotic? So every single one of those like 45 flybys does this. This is our 10 hours. We hustle through, collect our science in the intense microwave kind of environment around Europa. And then as we get further and further away, at 66,000 kilometers away, we turn our stuff off. We take our big antenna, we call it back to Earth and be like, hey, these are all the really cool things we just learned. We point our solar panels at the sun and we're like, give us more energy, because it takes 14 days to go out in that long looping orbit to come back around and do another flyby of Europa. So 14 days to make that whole trip once. And then this part, the whole 14 days pretty much is for these 10 hours, which we collect a bunch of science, a bunch of data, and then it's going to take scientists years, long time to sift through or like go through all of this data, all the numbers, to help us learn new things, because we collect it all, right? Like if you go to the beach and you collect a bunch of shells or collect samples when you're in science class, it takes you time to look through the data, look through those shells, see what you can find and learn, because there's so much more information that you can learn about it. So we're going to be sending this spacecraft in 2023. We got some time to build it. And now the question is, how long is it going to take to get there, right? Because we're going all the way up to Jupiter. So it depends. There's two rockets that we're looking at. One of them doesn't exist yet. You may have heard of the SLS, or the Space Launch System, the new rocket that NASA's building. If it's ready in time, we can use that one, and it would only take us 2.5 years only. Like, that's a long time, right? But 2.5 years is fast to get all the way up to Jupiter. That's super fast, because with rockets that we have right now, the other one we're looking at, it would take us 7 years to get up to Jupiter, because it's not as big, it's not as powerful. We have to fly around Earth like twice, and we steal some of Earth's gravity, and it shoots us out to Jupiter. But we got to build up all that speed. It takes a while to do that. So we talked about the really close images, right? High resolution images of the surface, because this Europa Lander, this is the other mission I worked on while I was at NASA JPL. So Europa Lander is not officially happening. You're like, why? Well, what NASA did, there's NASA headquarters. NASA headquarters asked all the different NASA centers around the country, like, look into these things. So one of them was Europa Lander. They're like, okay, we know Europa is the best place to find life in our solar system. If we were to send a lander to the surface to look for the signs of life, what would it look like? How much would it weigh? What would it cost? How would we do it? So we designed this. So this is one way to do it, where we have a box, and inside that box is all of our electronics, because we said, like, really close to Jupiter is not good for electronics. So we keep them safe in something we call a vault. So it's a thick vault, so it's harder for the radiation, all the bad stuff from space, to get in those electronics, so it can protect them. Then we got those 4 legs to help us land on the surface. We've got a robotic arm, you see it there, that comes out. It's got a saw and a shovel in the end of it. So you would saw into the ice down about 10 centimeters. See, Janet was right. All we use is metric units. So you got to learn centimeters, meters, kilometers. That's how I'm speaking this whole time. That's what we use to design our spacecraft.
And you know what, Kevin, that's what I love, because I go, this is so important. And you guys are at this age. Think of learning the metric system as you're learning a different language, and that you're learning the language of science, right?
Yeah, the language of science. And it's easier too. It works in tens. So like 10 centimeters, 10 millimeters, 100, like those are easier than doing 12 inches is 1 foot. How many feet are in a mile? It's like 5,000 and something, right? But for kilometers, it's in tens. And it's easy to count tens, right? 10, 20, 30, 40, 50, 10, 100, 1,000, 10,000. Janet's right. It's the way to learn, and do it now. So we're going 10 centimeters down in that ice to see if we can get a sample, use our shovel, scoop it in, put it into our belly. So if you can see the little thing on the front, it's got a little hole. We put it in our belly, and inside of the belly has a microscope, other types of science instruments like spectrometers, which is a big word, but essentially we're looking at different light bouncing off of our sample. So we like have some light and we take a look at different lights, different colors show up, and it can tell us a lot about what we're looking at. So think of it as all the things that are made up of stuff. So we got our elements, we got our carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. They each have their own fingerprint. So we all have fingerprints, right? Well, they have a fingerprint that shows up in like a rainbow. So there's different colors in this line that we can take a look at with a science instrument. And depending on how many colors there are and how thick those colors are, it'll tell us what element or what item it is that we're looking at. So we've got all of those devices inside our belly to take a look at the ice that we put inside, and hopefully it doesn't melt. We try and keep it cool to then look for the signs of life. So if this were to happen, NASA's still trying to figure out if they want to do it. We would launch in about 2030. That's a long ways out, right? So 2028, 2029, 2030, so in about like 7 to 10 years or 8 to 10 years. And then it would take us about 3 years to get to Europa. Then we'd land on the surface. And I told you that Europa Clipper was 2.5 years flying around, right? Well, this one, where are the solar panels? We don't have any. Where's like the nuclear reactor? We don't have any. So it's just batteries. Yeah, batteries like what you have, you know, in your computer mouse or in your TV remote control, so that your Europa Lander has enough batteries to only be alive for 20 days. That's a very, very short amount of time, but that's the best way that we can land on the surface with money that is not crazy, right? Because everything costs money. So without being too crazy expensive, the best thing that we can do is be alive for 20 days, take 3 to 5 samples, put it inside of our belly, and see if we can find aliens. So this is one that I'm really hoping comes through, and that we can go out and possibly find aliens in like 15 years. How cool would that be? Now, we want to get into that ocean eventually, right? Because right now, what we're seeing here, we see the ice crust. So once we learn how thick the crust is, then we know if we have to melt or drill, saw, dig, however we need to get down into that ocean with like a submarine. That's tough. So I'm going to need you to help me out, right? NASA needs you, because we need the new minds. We need the young explorers, the people who are creative. Like there we go. You see on the right-hand side, there's Europa. So we're looking to discover life under the ice, and we need your help to design the submarines, design the new rockets, the new spaceships. So it's going to take a while to do all these things. So we're going to need all the help we can get from all corners of the world. So we need everyone working together to help us find these aliens and eventually get humans out to Mars. We all need to work together to make that happen too. So we need you to get to NASA. But how did I get to NASA? So I wrote a book on it. It's called To NASA and Beyond. It's available on Amazon and Audible. But you don't have to buy the book. I'm going to tell you about it right now. So it took me a long time, and I failed a lot. So once I got into college, I wanted to work at NASA as an intern. So that means you only work for them for a couple of months. They kind of test you out. They see what you're like, maybe a summer job, and then you go back to school. Well, it took me 3 years and over 150 applications to get my first NASA internship. They just kept on saying no, but I didn't give up, and eventually it made it happen. So then I went on and I moved on. And I'm like, okay, I want to go to school at Georgia Tech, the Georgia Institute of Technology in Atlanta. And they're the only they're a laboratory in the country that's connected to NASA in the way that they are, with doing the complex puzzles that fit together, right? Like the systems engineering I talked about before. So they actually, that's the third bullet there. You see Georgia Tech, they denied me admission to graduate school. They're like, you did a good job, but it just wasn't good enough. But eventually, just 3 weeks later, I was talking to the dean of admissions, the guy who says, yes, you can come in, or no, you can't. And he's like, okay, I hear you're really passionate about wanting to come here and working for NASA. We're going to let you in. And then he's like, and we're going to pay for it all. I'm like, what? So I went from being rejected by the school to then them paying me for school. And then lastly, it's like, okay, now it's time for NASA, right? It took me 3 rounds of interviews to get to NASA, had an 8-hour interview. For 8 hours, they asked me questions. And they're like, I had to give a presentation like this to a panel of NASA rocket scientists, which was the scariest thing ever. And then 2 weeks later, they're like, well, you know, you were good, but not exactly what we were looking for. So I went through this process, and then NASA didn't give me a job. So I'm 2 weeks or 2 months away from graduation of 19th grade. And I'm like, I don't have a job. So I graduated without a job and took a 10-week internship to prove to them that I belonged. I'm like, NASA, like, I want you. Like, NASA wants me. No, not yet. NASA, I want you. And throughout those 10 weeks, I worked really, really hard. And I talked to over 30 people asking them to hire me on as a NASA rocket scientist. And on the last day of my internship is when I got told, yes, we will hire you as a rocket scientist. And then they had me working on Europa, the most advanced mission that they had. So just to recap my journey into NASA, it was 3 years and over 150 applications before my first NASA internship. Then Georgia Tech denied me like admission into the school, but then let me in and then paid for it all and gave me money to do research on top of it. And then after 3 rounds of interviews with NASA JPL, they said no, but then I took a 10-week internship. 30 interviews later, I became my full-time NASA rocket scientist working on the most advanced missions that they had, trying to find life on other worlds. Now, that is an intense story, right? It kind of seems scary. Not everybody has the same journey as me. Some people have it a lot easier. And I hope that your journey into NASA is easier than mine. And it's possible. There's a few people who it just works out a lot easier, where you're able to, you apply, you get the job. But the reason I share that story is to tell you that it's not impossible and to never give up. Like, you can make it happen if you're willing to put in the time, make the sacrifice, be dedicated, and put in all of that hard work and the effort to never give up. You can make your dream come true. So whether that's working at NASA, SpaceX, heck, if you want to be a hairstylist or an actor or a teacher, and you're coming up against people telling you no, if you keep on pushing, you truly believe in yourself, you can make it happen. So I want you to make it happen. I believe in you. My story hopefully will make you believe in yourself as well. So NASA wants you. So if you're going forward with the engineering or the science, anything in technology or mathematics, go for it. Make sure you have that why, something that's a little bit to help you through when it gets tough. And hopefully, maybe that why is Janet's Planet, right? Or maybe it's me. So you can come back here, maybe watch this, 10 years down the road when you're having difficulty at school, and it was like, oh yeah, it was Kevin who told me I could do it, or maybe it's Janet and her amazingness that you need to go back to and be like, Janet, I need some more motivation. Can you just tell me you got this? And I'm sure that she'll do it. Yeah.
You bet I will. Oh, Kevin, you've just given us pearls of wisdom and everything. So guys, let's go in if that's your last slide, why don't you close your share screen? I want to go into gallery view once you stop screen sharing. And
I'm going to show one last thing.
Oh, absolutely. And then we're going to go into question mode.
Yeah. So Janet has Janet's Planet and she's teaching amazing things. So what I'm doing, if you're interested, is I make videos. Right now, I'm teaching a live space class every Tuesday and Thursday at 9 a.m. Pacific. So that's 11 a.m. Central. So in about...
Right after our class. So you can leave Janet's Planet, go over there to a place called Space.
Yeah. So it's youtube.com/a-place-called-space. And today I'm teaching all about eclipses. On Tuesday, we did, as you see here, it did the moon phases with Oreos. So grab a package of Oreos, watch this one. You can make the phases of the moon with me there. So if you're looking for something to do after this at 9 a.m. Pacific, I'm going to be teaching more on a place called Space.
Perfect. All right, guys, you guys have, and I think Kirsten, it was interesting. Kirsten asked the question of like, how much education would you need to become a rocket scientist? And thank you for super beautifully covering that. So Kevin, here's what I want to do? I'm going to Venmo you the money for you to, and then Kirsten, if you will do this for me, if you'll send me your mailing address, I will get that book to you. And so make that book out to Kirsten. I'll email you about that. But it sounds like you're pretty interested in becoming a rocket scientist. So I want you to read his NASA and Beyond story. So in a round robin kind of way, let's ask some questions. I'm going to go down here to Seth and William in Cape Town. They're calling all the way from South Africa today. Good afternoon, gentlemen. How are you?
Good.
Good. So what's your question for Kevin?
How do you know that moons aren't planets?
Ooh,
How do I know that moons aren't planets? Good
great
question. So a moon is something that orbits something bigger than itself. So if something, so the planets have moons that orbit them. So that's how we determine the difference is if something is getting orbited by other things, it's the planet, where the moon orbits something else. Does that make sense? Yeah.
Awesome. All right. So we're going to come up here to Lucas. Be sure to just do this if you live long and prosper. Let me have a little hand raise if you've got a question, because I have a question for Kevin, but I'm going to hold it and see if one of you guys ask it. Lucas, what's your question, dear?
My question is, I'm just gonna say how you doing in the quarantine.
How am I doing in the quarantine? I'm doing best I can, right? I'm trying to stay healthy, make sure I'm washing my hands a lot, make sure when I go outside, I wear one of the masks.
Going outside a lot and a lot and a lot.
I'm not going outside that much. I have a backyard I can go to, but that's about it. I don't go too many other places because we want to make sure that
I want to go
we
the
flatten this
outdoors.
curve.
I go with my backyard, so that's the only place I can go to.
Yeah, it's like that's kind of like us, Lucas. It's like, but you know what? Thank goodness we've got a backyard. Some people
Yes.
don't have the luxury of that. So that's pretty awesome. All right, I'm coming over here to Evie and Maggie. What's your question?
Have there ever been any female Eagle Scouts?
Have there ever been any female Eagle Scouts? Not yet. So it was just recently, I think it was maybe 2 or 3 years ago that girls were allowed into the Boy Scouts and then become Eagle Scouts. Because it used to be Boy Scouts and Girl Scouts, just those two. So doing that. And there was, I don't know what the highest rank in Girl Scouts were, but it hasn't been that long that girls can be in Boy Scouts. So there hasn't been enough time for some females to go all the way through and become an Eagle Scout. Now, the one thing is you have to become an Eagle Scout before you turn 18. That's the age limit. So I became an Eagle Scout 1 week before I turned 18. So I kind of pushed it to the end, but you could be the first one.
You could be the first girl. That would be amazing. But remember this, when you are kind of creating your resume for college, starting even now, how many space camps did you attend? How many theater camps did you attend? How many reptiles did you foster? Because I know you're a reptile kind of gal.
Cool.
And so that you keep up with this. So by the time that you're getting interviewed for college or an 8-hour interview from NASA, you have got to, even though you may be young, you've still got a lot of experience that you can say, well, I attended this and I joined the Boy Scouts. So become an Eagle Scout. So you can do tons of things. It is, however, up to you to investigate and research what those opportunities might be. But I'm proud of you for thinking that. All right, coming over here, Judah. I'm just going to kind of go around as kind of like the way that you're appearing on my screen, and then I'll come to that second page. Judah, what's your question?
So I have 3 things. One is one of your slides.
Yeah.
The picture of Europa, there's something in the top left corner.
Let me bring that back.
You have to know, Judah, I'm just going to go ahead and speak this over him. He is a mighty observational scientist. So he's going to be the guy you want on your team that's going to be like, hey, what is that detail? An integral team member here.
Are you talking about this right here?
Where? Yes, that picture.
Yeah. Yep.
No, the other one. 4.
That one.
Yes.
This one?
Mhm.
The tiny Europa,
The
like
tiny Europa.
under it. See
The
the
little black bar.
no,
Little black bar.
no.
Hmm?
Looks like it's lighter than all the other part of the pictures.
Oh, I bet that's an impact. Is that an impact on the crater? Is that on Europa?
Hold
Are
on.
you talking about, let me see if I can get my cursor in here. My cursor is not showing up. But yeah, are you talking about like, it looks like a white circle on the bottom?
Yes, on
Yeah.
the top.
So, on the top?
Okay.
I guess my cursor isn't showing up. Otherwise, I would love to be able to. Okay, here we go. So the cursor's coming up. So are you talking about this part right here?
No. No.
Is it?
Let's go back to you're talking about this area there that's showing the white-most part, the shiny kind of part.
Yes.
All right, so the most light part there.
Not on the tiny Europa.
Not on Europa. I guess I'm not
Wait,
understanding.
before the tiny Europa, under the word Europa. See the light?
Oh, I think I know what you're saying. That's
Yes.
just the edge of the photo. So the picture of Europa is on the background with a bunch of stars. And then on that top left that you see there, that's just the edge of the photo where there was some more stars and it was cut off.
But a brilliant eye, Judah. It's proof that once
Yeah,
this
you're talking about-
quarantine is over, I got to get new contacts. But thank
can
you
see
for
it right
that,
here.
because
Yep.
no, you're again being observational like that, because if you were trying to delineate in some research and you got that back, you would want to
Mhm.
know, is that something that's being shot out into, from one of those plumes and everything? Let me come around. Kirsten, anybody, you have any questions, Kirsten? Let me unmute you there. What's your question?
There we go.
No, I don't have any questions.
All right, Kiri. Okay. Anybody else as I'm coming around? All right, I'm going to go to this. Okay, Rose Gold. What is your question?
My question is, how do you know if how do you know if it's it what how do you know if the how do you know if the atmosphere around the planet is strong or weak?
Has
Ooh.
sprung a leak?
Sprung a leak or strong or weak?
Strong or weak?
Strong or weak?
How do you know?
So how do we know if the atmosphere around a planet is strong or weak?
Mhm.
One of the ways that we know about that, there's two couple ways. So one here on Earth, like a magnetic field. So a magnetic field is what helps us protect our atmosphere here on Earth. And Mars's magnetic field went away. It's like really small. So it has a thin atmosphere because it's not protecting from all the sun wind and particles that are shooting. So it's like taking it away. And then we can use telescopes and other science instruments on spacecrafts that are out in outer space to look into the atmosphere and figure out what it's made of. And that can help us determine how dense it is. So density is how close things are packed together or how far apart they're spread. And we can see how much light is able to bounce around or get through it. And if we can't get light through it, it means it's pretty dense, pretty thick and strong and put together.
That was an awesome question. All right, I'm coming over here to Nick and Nia. All right, my friends, what's your question, Nia?
What was it like to be an American Ninja Warrior?
What was it like to be an American Ninja Warrior? It was a lot of fun. I will say the other ninjas, it's like it's a family. So I used to do some other sports where people weren't as nice to each other, but for American Ninja Warrior, everyone's really, really nice. Like if I would have gotten one obstacle further and maybe that meant somebody else couldn't go on, they would have been cheering me on to hope that I get it, even if that means that they don't get to go on. So it's so much fun because everyone's really nice. It's a good community. And then it's a double challenge. You know, you need some strength with your body to figure it out, but then your mind too, because each obstacle is like a puzzle. And you're like, how do I do this? What's the best way? Because everyone's body is different. So you have to figure it out with your mind, do it with your body as well. That's what it's like. And it's always failing. I'll say that, because not everybody like completes it. Like we've only had 2 winners in the last 11 years ever make it all the way through, but people keep coming back. So it's learning to fail or to not succeed and then get back up and do it again. It's a lot of fun. It's challenging.
Well, and how many hours a day would you work out or train? Like, what was your workout or training schedule? Because in a way, I mean, you're training like an Olympic athlete, because that is tough stuff. And I would think the upper body strength is something, and you're really super tall. So you got a lot of mass you got to move around, right?
Yeah. So mostly training can be anywhere from, 30 minutes to 2 hours a day in the off season. But when we're building up to competition, so like the 4 months before competing, it can be 3 to 5 hours a day. But you don't want to push too hard, because when you're working out right is when you're tearing your body down. It's when you're not working out, when you're done, that your body builds back up. So if you're working out too many hours, you're not going to be able to recover enough to hold on to those obstacles for the long amount of time.
Beautiful. All right, Judah, I know I'm going to come back to you, but I'm trying to get everybody a question, and I promise I see you. All right, let me come down here. So the next row that I see is Jesse. What's your question?
Can like a very large moon somehow build an atmosphere?
Yes. So Titan, one of the moons of Saturn, has a very, very thick atmosphere.
Yeah, and here's the thing about Titan is that some people would rather advocate that humans go to Titan versus Mars, because it has its own substantial atmosphere.
We could live on it.
It has lakes of methane on it, so we'd have rocket fuel. But again, you got to think, when he was talking, remember, to communicate with Mars, traveling at the speed of light's 14 minutes. So if we go on out to Jupiter and talking to Europa, it's 30 minutes to an hour. We get on out to Saturn and to Titan, that is at least a 2 hour, like we send a message, and then think about this, 2 hours from now, we're going to get an answer. So I want to, let's see, I see Ander. Kevin, remind me about my question, but it's like Titan is super cool, because if a human could don a pair of wings, its atmosphere is so kind of like dense and its gravity so low
that would be awesome.
All you have to do is like fly about. I would love that, right? That'd be cool to go do in my backyard.
Human wings would be awesome.
I know, right?
Love that.
I know. It's like maybe one of these days we could try that out. All right, Ander.
Build wings.
I see that hand over here, Ander. What you got?
So can moons have clouds like planets?
Can moons have clouds like planets? Yes, but you need an atmosphere. So what we were just talking about, Titan has clouds. We initially thought Titan was bigger because its atmosphere is thick and there were a lot of clouds that we couldn't see through it. So when we first saw Titan, we're like, oh, it's like this big because there were clouds and atmosphere. And then when we got better cameras and telescopes and spacecrafts, it actually got a little bit smaller, because then we were able to see the difference between the atmosphere and then the moon itself. So yeah, you just need an atmosphere to have clouds. So moons can have them too.
Great question. All right, Tapa Swinney, you've been asking several amazing questions. Here's what we're going to do. We're going to go to Tapa Swinney in India, then we're going to come back to Judah, and we'll close out with our time with you. Thank you so much. But Tapa Swinney, you take it, and then Judah, you'll take us the last question. Okie doke.
So the magnetic field of Jupiter disrupts near the area around Europa. Why does this happen, and could it affect any future space missions to Europa?
Good question. So I'll repeat it for everybody. Is the magnetic field around Jupiter seems to dip around the orbit of Europa. Why does that happen, and can that affect future space missions? Why does it happen? Not exactly sure. So one of the instruments on the Europa Clipper is a magnetometer. So that helps us determine the changes in magnetic field. And we're going to have that on while we're in that 14-day orbit around Jupiter, and then the 10 hours that we swing by Europa. So we're going to be collecting a lot of magnetic field data to understand. And at first guess, I would say it's because of the large presence of water that's at Europa, and it doesn't have a magnetic field of its own. There's a rocky core, not an iron core. So I'm guessing, this is not my expertise, but that large amount of water can perturb the magnetic field by shielding it, because water shields us from radiation is one of the things that we see. So that might be an answer, but we'll have to wait until Europa Clipper collects all that data to help us learn more about it.
Do you have another question, my dear? All right, so coming over here, let me go back to this previous page. Judah has two, and then I want to ask my question. All right,
Okay.
Judah, what you got?
So did you ever feel like when Georgia Tech and NASA hired you that they just did it so you'd stop trying?
Yes and no. So with Georgia Tech, yes, I feel like I was being maybe a little annoying, and he's like, okay, how can I get this kid to stop? But have you heard the phrase, the squeaky wheel gets the oil? So you got to make your voice heard and known. If you don't fight for what you want, you may never get it. At NASA, it was different. NASA hired me not because they were getting annoyed or like I kept on, they didn't want me to speak anymore. They hired me because I was the right person to hire, or one of the people. They saw my work over those 10 weeks. So the reason I didn't get the job in the first place is essentially they didn't know me enough. They never saw my work. The way into NASA 95% of the time is through an internship. So they see your work. They do we get along well? More than a 1 hour or 8 hour interview. It's 3 months of, do I want to work with this person every day? Do we jive well? And then also, can I trust their work? Are they good? Because there's so many people that have Georgia Tech or MIT or Caltech on their resume, but it's the practical application and working in a team together that really allows you to get in. So Georgia Tech, yeah, they just gave it to me, I think because I was being annoying, possibly. I did have the basis to succeed there, so I was really close. And then NASA, they did hire me for being what they were looking for in an employee.
And wouldn't we be moons since we orbit the sun and it's bigger than us?
No.
No.
So depending on who's listening, for which age group, I can give different answers to what a moon is. So on the basic, so moons are something that orbit something larger than themselves. If you're orbiting a star on a predictable path around the star, and you have enough gravity to pull yourself into a sphere, and you have enough influence to make everything around you a moon or kick it out of your orbit, then you're a planet. So first off, we look for, like, let's say it's a galaxy first. You can get classified as a galaxy. Then you can get classified as a star. Then you can get classified as a moon. Then you can get classified as a dwarf planet, and then a moon around a dwarf planet. So it's kind of like a hierarchy or a level of things. So there's little caveats, but very observant. Good question, Judah, to understand that. Well, wouldn't planets be moons then too? So you're listening. I like it. I like how you're thinking.
No, I'm telling you, Judah, it's like, here's the deal. You're going to become a scientist, and I am so proud of that. I should probably get your autograph now. So I've got two questions.
Janet's question, yes.
So one just occurred to me. I want to know the most interesting question they ask you in that 8-hour interview.
Ooh. There wasn't, that I can recall, any like trick questions, right? Where like Elon Musk has a favorite question that's been a meme that's floating around. I don't know if it's true or not. Where it's like, you start at the North Pole, you go a mile south, mile west, mile north, where are you? There wasn't any like trick questions like that. So the most difficult question, I think, for me was like, where do you see yourself in 10 years? You know, because it's difficult to predict that far in the future, and like, you know, wanting to learn details. They're really trying to get a sense of what your ambition is and where you're trying to go. And my answer to that was, I don't know, because I'm going to learn so much more in the next week, the next month, the next 5 years, that my path is going to pivot. It's always going to be in space exploration. It's always going to be about these planets, these moons, these spacecrafts. Where that will lead me, I don't know. And I look to someone who's been in the industry longer than I have, who knows more, to help mentor me in making that decision. So I answered the question by not answering the question, and that was probably the most difficult one.
But you know what, kids, hear him when he says that, is that he was honest. It is so much better to absolutely say, I don't know, than to proceed with an answer that either you're going to have to live up to or be found out that it's incorrect. So the honesty, it's like, you know, you guys ask me questions all the time and I'm like, I'm going to have to look that one up. Again, guys, life is a constant state of learning and becoming. And so the more that we do that and admit that it's like, I don't know. The last question I have heard that Europa, that there are some scientists believe, and after this brilliant mission, the Clipper, we may know more, might be a place where we could really grow a lot of food. Can you talk to them about that at all?
A lot of food. I actually have not heard that theory yet. Interesting. If so, I'm guessing that it would be about the water that can help us with that.
I think that's why it's like they're going, if that's a basis for life, and we know that it you know, it's blowing out these plumes of things. So here is our assignment, guys. So the reason I wanted to ask that question is we're going to, and you can just be a little paragraph. You're going to write down your answer of where do you see yourself in 10 or 15 or 20 years? What's your ultimate goal? It's a great exercise. And if you just go, Janet, no clue, or here's what I think, here's what I hope to bring to light, that might be just a really fun exercise. And if you want to share it and you send it to me at janet@janetsplanet.com, I will send it on to Kevin, and we'll just kind of enjoy kind of like cheering each other's future successes on. I know where I want to see Kevin in the next 5 to 10 years is walking on Mars as a NASA astronaut. So that's my hope for him. And lastly, let me tell you, tomorrow is astronaut Hoot Gibson. The day that we had him before, we had switched to Google Hangout. We were trying a ton of things. Tomorrow is going to be phenomenal because he's going to be able to share his slides here on Zoom. So if you know of anybody who wants to hear a 5-time space shuttle astronaut talk about his experience, Kevin, you're welcome to join. Hoot is amazing. Is join that call tomorrow. Okay, so tomorrow is all about astronaut Hoot Gibson. Next week, probably in the next newsletter that you'll get kind of like tonight in your inbox is going to kind of tell you what we're having next week coming up. But Kirsten, please send me your mailing address, and then Kevin, I'll coordinate with you about that book. You guys are doing fantastic work. Miss Sydney Swanson is super impressed. So is Dr. Susan Ipjewel. For those of you who have sent in your body map, look at those due dates that were in that newsletter last night. And again, guys, go and continue to be awesome. Remember this, the universe is always expanding. Let your mind do the same thing. I'm going to unmute everybody, and I want you to, is there like an American Ninja thing you guys say, or a kind of handshake, or an I love ya? How do American Ninjas say goodbye?
Wait.
Don't really have one.
Don't really have one. So everybody say thank you, Kevin.
I don't know.
You're welcome.
You do have a question?
Bye.
All right, who's saying they have a question?
I have a question.
Yes. All right.
Hi.
Okay, I'm gonna do you and then Ander. Where are you? All right, coming to you. Yes.
I was trying to look up something. But what's the assignment again?
So for the assignment, again, totally voluntary, right, is to write kind of a paragraph about, or maybe you can even bullet point where you see yourself in 5, 10, 15, or 20 years from now. Your goal, kind of like as you see it now for your life. And remembering always that if I look back at what I may have written at age 10 or 12, is ended up being totally different. You know what I thought I was going to be when I was 10 or 12? I was going to sing country music and I was going to like travel the world. Now I was in a band called Summer Rose and Ivy, and we got very close to having a record deal, but about like they had just signed Shania Twain and Toby Keith, and we were the next girl band that was going to be signed. Then Mercury and Polygram merged and our record deal went away. And at the time I was performing at a theme park, singing and dancing for kids. So when I was your age, I love my science, but I definitely thought I would be performing and stuff. But the good news is I have still found ways to be an actress. Yesterday, I did a voiceover for something. And so it's like there are variations of a theme still in my life that are based in what I wanted to do. But in high school, I won the science fair. And so there was this love of science that was also there. So again, know that whatever we put down on paper is simply kind of a guide to kind of like just keep us motivated, moving toward those things that are most important to us. All right, you guys, go make it a great day. And I'll see you tomorrow with Astronaut Gibson.
Bye.
Bye.
Hi, everyone.
Take care.